Now that we've been talking about the graphical solutions, let's actually start looking at finding the actual solutions to differential equations. And we're going to start with a particular type of differential equation called separable equations. Separable equations are first-order differential equations with a particular property with them. I should be able to write them in the form dy dx equal to hx gy. So the left-hand side should only have the derivative. The right-hand side, I should be able to break it up as a product of a function containing the dependent and a function containing the independent variable. Here we have a differential equation, dy dx equal to 2x plus xy over y squared plus 1. So first, we want to actually write this as a separable differential equation. Well, if I look at the right-hand side, I can start by factoring out an x on the top. That gives me dy dx is equal to x times 2 plus y over y squared plus 1, which we can then write as dy dx is equal to x times 2 plus y over y squared plus 1. So now I have my two values. I have this x value, that'll be my h of x, and I have this huge fraction, which would be my g of y. So I've written it as something involving x times something involving only y's. So this is a separable differential equation. Let's look at a couple more. Here I have dy dx is equal to 1 plus xy, and this is an example of something that's not separable. In particular, this right-hand side, I can't factor it like I could the last example. So I won't be able to separate the x's and the y's because, in particular, of this plus 1. What about dy dx is equal to x minus 5 over y squared? This one I could rewrite as x minus 5 times 1 over y squared. So once again, I have my h of x, and I have my g of y. So this one would be separable. Now let's take a closer look at this example. So how do we actually solve these separable equations? Well, our first step would be to get the y stuff on one side and the x stuff on the other. So let's start by multiplying both sides of this equation by y squared. That gives me y squared times dy dx is equal to x minus 5. So I got all of my y stuff on one side. Everything involving y is definitely on the left. However, I'm also going to multiply both sides by dx since that is some of our x stuff. So now we have y squared dy is equal to x minus 5 dx. So now we have y stuff on one side and x stuff on the other. Our next step is to then integrate both sides of the equation. So now I'm looking at the integral of y squared dy is equal to the integral of x minus 5 dx. So let's go about integrating this. The left-hand side, the integral of y squared would be 1/3 y cubed plus c. I'm going to call that c1. On the right-hand side, the integral of x is 1/2 x squared. The integral of negative 5 is negative 5x. And then I need that constant of integration, which I'm calling c2. From here, we actually want to solve for y. So I want to be able to get y equal to something for my solution. So we start by subtracting c1 from both sides. I then multiply both sides by 3 to get 3 halves x2 minus 15x plus 3c2 minus 3c1. It's important to realize that this thing right here is still a constant. So as a result, I'm just going to write c to mean 3c2 minus 3c1. From there, we can take the cube root of both sides. And when I do that, I get y is equal to 3 halves x squared minus 15x plus c to the 1/3. So it's important to realize that this is actually a family of solutions. Different values of c will give different functions, but all of the solutions to this differential equation are going to look like this.